Hey everyone, welcome back to the shop. So what you're looking at here is an air rifle I made probably a couple months ago out of an old SodaStream tank and an airsoft barrel. Basically, it's just a super simple mechanism with a fast-acting valve and a gravity-fed clip that could shoot around 15 airsoft rounds a second at a pressure of around 150 psi. But I was thinking about this the other day while I was looking at it, and I thought back to an old Nerf gun that my friend had called the Nerf Mag Strike. Now, if you don't know what this particular Nerf gun is, it is a hand-pumped gun. You build pressure sort of like a water gun, and when you hold the trigger down, it fires fully automatically and even feeds a clip up through the body of the gun. Looks super cool, super satisfying to fire. So I got to thinking, what would it take to basically reverse engineer that mechanism and implement something very similar to that on this, I guess, base of an air gun. I found on the Nerf Haven forum a post by Gas Mask Guy, I think was the username. But basically he had done the same teardown I did, but he had a really thorough explanation of the entire mechanism behind it. And I decided to use that as a building off point to try and make something compatible with this tank here. My basic requirements / limitations for this project were, first, obviously I wanted to use the tank and trigger mechanism that I had already assembled here. And secondly, instead of airsoft BBs, I wanted to try and make it compatible and use these hunting pellets. They are 22 caliber pellets with these cool little spikes in the front to help the mushroom. They're just what I had lying around, and it would be a lot cooler than just some non-accurate lightweight airsoft BBs. So first things first, I need a new barrel. This is the old one I was using. It's just the old barrel out of an airsoft shotgun I used to have, and I flanged the end, and there's a little flare fitting cap on there, and that's what I use to interface it with the chamber portion of the gun. But those airsoft BBs are obviously a lot larger than 22 caliber pellets, so I bought this very long barrel. It's just a 6-foot length of 22 caliber tubing off of McMaster. I think in the final gun I'll probably use 3 feet or so. That sounds, I don't know, that just sounds like a nice number. But first of all, I think it would be pretty fun to interface this entire 6-foot long barrel with the previous tank and valve I've already got on there, and just see how fast I can get a pellet going with a 6-foot long sniper rifle barrel. So okay, that was pretty cool, but it's time to actually start designing this thing. So first, I'm going to break down the mechanism, the firing mechanism, how it works, and then I'm going to have to try and figure out a way to scale it up and make a full metal high pressure version. This is the diagram I found on the Nerf forum. I just printed it out so you guys can see it, but it's a really good way of explaining how this entire assembly works. The main part of this is the main air chamber here and the main spring behind it. Essentially what happens is air is fed in through the back through this tube, and there's not a really good way of seeing it, but it comes out on the other side of this plunger here and begins pressurizing this chamber. As the air keeps flowing in and it keeps pressurizing, it moves this piston back, this plunger back, compressing the spring. This blue piece at the front of the chamber is a stopper, a little seal, to seal off the chamber, holding the pressure in here. But as that piston keeps moving back, eventually there's this little lip here that bottoms out a spring and pulls the stopper out of the end of the chamber, allowing air to flow out the barrel. There's a spring between the stopper and the main piston that just helps bias the seal away from the exit of the chamber while the air is flowing out. That way it doesn't immediately seal as soon as it begins venting. It gives this plunger some time to return back and force out all of the air in the chamber. That was kind of a broken explanation, but by looking at this long enough, I'm sure you'll be able to understand the mechanism behind it. With that understanding in mind, here's the just basic starting point of the engineering behind the scaled up version. I've done a little math here, and the limitations I've set are, I'm assuming it's 150 psi input pressure, but the mechanism should function all the way down to 100 to give it a good amount of range. I'm not going to go through it all, but essentially it's engineered so that at no point in time will there ever be a pressure in the system that is less than 100 psi. So even as it's firing and the pellet's all the way at the end of the barrel about to exit, there's still going to be at least 100 psi of back pressure behind it, forcing it out. And through some more math, I've figured out that that's basically going to guarantee that the muzzle velocity will never be below 415 miles an hour. At maximum operating pressure, I'm sure it will be higher, but I've based the engineering off of setting some bottoms, some minimums that I don't want to go below. So I can tell you the minimum will be 410 miles per hour muzzle velocity. So this is obviously not really like any sort of design. It was just sort of me figuring out chamber lengths and spring forces and pressure differentials and whatnot. So now I've got to actually put this into some CAD and start turning this into a real design. And here's what that sort of looks like. This took a lot longer than I thought it would, but here is the model of the entire assembly in CAD. Now, this is the initial CAD model. It is not a final design by any means. Like, if you assembled this as is right now, it wouldn't function at all. What this is for is, one, getting the dimensions locked, figuring out exactly how big everything's going to be and how long everything's going to be. And based off of that, what this allows me to do is begin to order materials. There's obviously a lot of tweaking that needs to be done here, but I know for a fact that these are the pieces of stock that I'm going to need. These are the diameters of the tube I'm going to need. And no matter what kind of tuning I do in the details of the CAD, I can still use this as something to order my stock off of. So that's the V0. This will still there's still a lot of work that needs to be done. But it does certainly bear a resemblance to the diagram of the original. So let's order some stock. That is a lot of metal and a lot of springs. The sizing of the springs took absolutely forever because finding the right amount of force versus the maximum amount of travel, the rate, the spring constant, there's just so many variables in sizing those. That's what took the most amount of time, but gotta love McMaster. 16 hours after I ordered it, this all showed up at my door. So, as you may have seen in the original CAD, I'm actually using two different size springs. or they're the same length, but as you can see, the spring constants slightly differ. This was again part of that process of me trying to find the perfect balance of travel and force, but these combined, when they're bottomed out, or almost bottomed out, they will produce 106 pounds of force, which, if assuming my math is all correct, is what we want for good function down to 100 psi. So now that we've got all this, it's time to start machining. Alright, so I've just gotten the mechanism to work at least a little bit for the first time. So I'm going to real quick show how it works. I've got the CO2 on the back. I'm going to use it to charge it up to about 180, 190 psi, around there, just about 200. And unfortunately the mechanism stops reciprocating at about 100 psi, so there's a whole lot of tuning to be done, but if I fire it now, you can see. Okay, so before we get too deep into testing, let me slow down a bit and kind of explain what all the pieces do and what they're all for, because I kind of skipped over a lot of that in the machining. So here's everything, all the finished parts for the mechanism. Basically, the whole chamber looks something like this, as you saw in the cab, with the main body here and a cap right there. And these are all the inner workings. So to real quick go over how it works again, air is injected directly into the main chamber of the gun here. I know originally I said it would be coming in the back, but for simplicity's sake, I just put it straight in the side of the body. In that body, there's of course this piston, and when there's pressurized air building up here, it tends to want to compress that piston backwards and build pressure. The reason it doesn't escape all out the front is because there's this little Delrin plug which goes in the end of that front piston and seals against this silicone coated end cap. So when it's all assembled, there's a bit of preload pressing that plug into there, so that creates a nice seal. So as the chamber fills with air and pressurizes, as I sort of explained before, this gets pulled back because it's compressing the springs. The stopper on the front doesn't immediately get pulled back with it because of the air pressure pressing it against the sealing face here. But there reaches a certain point, because there is a spring in here, as I mentioned, you can see. Spring loaded. It reaches a point when the spring force from this spring exceeds the pressure holding the seal face shut, and as it's compressing backwards, all of a sudden, boom, poppet seal opens, all the air rushes out, the springs then expand, creating a burst of air, and then this sealing face slams back into the seal, shuts off the airflow, and then the whole cycle repeats. So a whole lot of machining here, but nothing too complicated. Basically just a bunch of cylinders and threads. But yeah, now that it's all complete, it's just really a bunch of tuning to do. I'm gonna adjust the spring force within the sealing plunger, play around with a couple other parameters, and just try and get it operating as best as I can. As far as the rest of the mechanism for the feeding of the Airsoft BBs and whatnot, or the pellets or whatever, that I'll have to figure out later. For now, I'm really pleased that this mechanism actually worked. I'll include a few more clips after this of testing footage, but yeah, until next time, thanks for watching.